Hi guys, welcome to the tutorial chapter 8 magnetism. Today you have a tutorial chapter 8.1 magnetic field B. Are you ready for this tutorial chapter 8.1? I hope that you have your tutorial question and also your answer in front of you. So it's easy for you to understand and can help you to answer all the question for this topic. Okay, let's look the question. Okay, question 1, question 2. Okay, question 1 is more to definition, and then 1B you have the magnetic field line, the drawing. Okay, and then also for question 2, draw the magnetic or sketch the magnetic field line. You can refer to your notes. Starting question 3 and above, you have a calculation part. Okay, but number 7, direction of the magnetic force. Okay, next question, calculation also until you have a question until number 20. Okay, again, I don't want to discuss all the question. Okay, for this tutorial, I choose some of the question. I think that is difficult for you to solve it. Okay, let's do the question by part. Okay, question 3, question 4, and question 5. If you realize that for this question, okay, is under the magnetic field B produced by current carrying conductor. Okay, let's do some of revision. Okay, current carrying conductor, you have a 3 type of the current carrying conductor. Okay, you have a straight wire, you have circular coil, okay, and then you have solenoid. Okay, for each type of the current carrying conductor, you have a different formula. So don't use the wrong formula when you want to solve your question. Okay, let's look one by one. Question 3. Okay, this is a straight wire. Okay, so your formula is B equal to mu naught I divided by 2 pi R. So your R is 20 meter here. You want to calculate the magnetic field. Okay, point your point, okay, to your center of your wire, which is the distance is 20 meter. Okay, so this is the value of your current. Okay, next question 4. Okay, for question 4, this is the circular coil. Okay, so formula is B equal to mu naught N I divided by 2R. Okay, you have 1 turn, so N is equal to 1. I think you got a problem with this question, which is the R value. Okay, you don't have your R value, so how to calculate the value of your R? If you refer to your question, you have a long of your wire here, which is equal to 3 meter. Okay, so wire is bent into a circular coil. Just imagine here, you bend your wire, okay, into a circular coil. So what happened to your wire? You have the length of your wire is equal to the circumference, the circle. Okay, so how to calculate the R? You have a circumference of your circle. Formula is 2, okay, pi R. So equal to 3 meter. So from this equation, so solve for the R, then substitute value R into your formula. Okay, then you can calculate the value of your magnetic field B. Okay, for question 5, you have solenoid. Okay, so this is your formula for the solenoid. U naught N divided by L times the I, current. So they want you to calculate the number of turn, the value of your N here, number of turn. Okay, you have a length of your solenoid Okay, the value of your current and the value of your magnetic field be in the unit millitensla. Don't forget to convert to the Tesla, the unit SI for their magnetic field B. Is it okay? So from this question, you need to know how to differentiate the type of your current carrying conductor, okay? And then use the correct formula for each type of your current carrying conductor, okay? Next, question 6, 8 and 10. Okay, I skip some of the question, don't worry. I will discuss later. Okay, for question 6, question 8 and question 10, this is the question or the problem under the force on moving charged particle in the uniform magnetic field B. Okay, first you have a formula to calculate the force, okay, on your charged particle, okay, in the uniform magnetic field B, FB, okay, equal to the QVB sine angle, okay. For question 6, okay, let's write the question here, okay. You have your charged particle value 0.100 microcoulomb, okay, and then the value of your magnetic field be 1.5, okay. Speed, the velocity is 5 meter per second, okay. If you want to calculate the maximum force, okay, but before that, let's look this figure, okay. So your V is perpendicular to the direction of your magnetic field B. So where is your V? Refer to this figure. Okay, you have your V here, the direction of your V and the direction of your B. Perpendicular. Okay, V is perpendicular to the V, means the angle between V and B is equal to 90 degree. Okay, so 90 degree. Okay, substitute into your angle. Okay, value sine 90 you get is equal to 1. So you got F is the maximum. Okay, so substitute your value in your equation, solve for the FB. Okay, you want to calculate the maximum of the force. So if you want to calculate maximum of the force, okay, you have the angle between the V and B is 90 degree, or V is perpendicular to the direction of your magnetic field B. So your formula only F, okay, you have your formula F equal to the QVB. Okay, is the same, okay, working solution for question 8 and question 10, because it's perpendicular. Your V is perpendicular to the direction of your magnetic field B. So you just solve by using the formula F equal to the QVB. Okay, but then if you have your angle, you need to consider between the B and V here less than 90 degree. Okay, so you need to consider in your calculation. Put the value of your angle into the formula here to calculate your FB, the force due to the magnetic field B. Okay, is it okay? Okay, before we go to number 8, I think number 10 is the same. Number 10 is same. Okay, you have your magnetic field direction here. Into the page, you have your angle to the right. Okay, so charged particle perpendicularly enter a uniform magnetic field B. So you have B perpendicular to the magnetic field B. Okay, so you need to calculate the value of your B. So you can use the formula. You need to use the formula F equal to the QVB. Okay. Do you have a question for number 8? Hmm, let's look the solution for number 8. Okay, solution for number 8 here. Okay, if you refer back to your question, the question is given the value of the energy. Okay, you can refer to the unit is in joule. Okay, so what is the type of the energy for this question? Okay, actually it's talking about the motion of the charged particle. Okay, if you refer, you have a value of your energy. Okay, and then you have a charged particle move with the type of with the energy. Okay, 5.2 times 10 power negative 70 joule. So what is the type of the energy? Okay, so what is the type of the energy? Now we're talking about the motion. So it's talk about the talking about the kinetic energy. So what is the formula for the kinetic energy? I think you are very familiar for this formula. Ke equal to half mv square. So by using this formula, calculate or solve for the value of the velocity of your charged particle. Okay. You have a square root 2, okay, time with the energy, the kinetic energy, and divide by the mass of your electron, okay, and then you can got the value of the velocity of your charged particle, and then substitute into your next formula to calculate the force due to the magnetic field B, okay, by using the QVB. Okay, is it okay? Is it clear? Okay. Force on moving charge particle in the uniform magnetic field B. Okay, this is the concept talking about the how to calculate. Okay, how to calculate the value of your force due to the magnetic field B. Okay, next let's look the direction. Okay, question 7. Okay, what is the direction of the magnetic force of the current in each of 6 cases? This question we already discussed, okay, during the lecture class, right? Okay, so I think you got the all the answer, okay, for this question. Okay, how to just some of revision, how, okay, how to find, how to decide the direction of your magnetic force. Okay, you need to solve by using the Fleming's left hand rule. Okay, your thumb, it shows the direction of your magnetic force. Okay, first finger is the direction of your magnetic field B, and third finger is the direction of your current in a wire, or is the same with the direction of the positive charge particle. Okay, let's just some of the revision for the Fleming left hand rule. Okay, so here you have your current direction when you switch on. Okay, close the switch. Okay, you have a current flow from the positive terminal to the negative terminal. Okay, that's how you apply the Fleming left hand rule. If you see from the side, okay, see from the side here, okay, you have a current is out of phase. Okay, and then the B, magnetic field B, is going down. Okay, remember the direction always not from the not pole to the south pole. Okay, then by using the Fleming left hand rule, you have your current is to the right. Okay, now changing the direction. Okay, switch on. Okay, now you have a current flow from the positive terminal to the negative terminal here. Okay, so if you see from this side, you have a current into the page. Your magnetic field same, which is going down. Okay, by using the Fleming left hand rule, you have a FB is to the left. Okay, so please check your answer. Okay. Fleming, by using the Fleming left hand rule. Okay. Next. Okay. Next question. You have a question 11 here. So let's do question 11. You have question or the problem under the force. Okay. On a current carrying conductor. Now you need to consider the length of your wire. Okay, then you place in the magnetic field B here. Okay, you can refer to this figure. Okay, first you have a formula to calculate the force on the current carrying conductor placed in the magnetic field B. F equal to I L B sine angle. Okay, so refer back to your question here. You have a angle, the direction B, and the conductor makes an angle of 30 degrees. So where is your 30 degree? Refer to this figure. Okay, so the 30 degree is B, from B to the conductor. Okay, so this is your B direction. Okay, and then this is your wire. So angle between the B and the wire here is 30 degree. So 30 degree you need to substitute into your formula to solve for the force on a current carrying conductor. Okay, convert the length of your wire into the meter 0.20. Okay, then you have a value of your current, substitute into your formula. Okay, the magnetic field B, okay, you must in the unit SI, Planck's law. Okay, so 1.5 times 10 power negative 3. Okay, then you can solve for the magnetic field force. Okay, is it okay? Okay, next question. We jump to question 16 and 17 first. Okay, don't worry. Later I will discuss number 12, 13, 14, and 15. Okay, question number 16 and 17 and 18 is talking about the torque on a coil. Okay, so first, this is your formula for the torque. Okay, equal to BINA sine angle. Okay, for question number 16, okay, number 18, okay, you want to calculate the maximum of your torque, okay, you can refer to this figure. Okay, where is the point, which is you have a maximum torque. Okay, so let's look. Okay, what happened to the value of your torque? Decrease, okay, 0, and then go to the maximum of the torque. So maximum of the torque here. So what happened actually? Okay, you have your plane. Okay, you have your plane, and then this is normal. Okay, again, let's look. Okay, your torque produced here, you have example here, you have your value of your circular. Okay, you have a plane here. Your normal always 90 degree. Okay, to your plane. Okay, and then you have your magnetic field B. Your magnetic field B always from north to the south pole. Okay, so let's say this is your magnetic field B. Okay, so your angle is here. 90 degree. So 90 degree, substitute into your formula. That is referred to the maximum value of the torque. You got maximum value of your torque, okay, which is your N is perpendicular to the plane, okay, or your B is perpendicular to the N. Your B is perpendicular to the plane, 90 degree. Okay, so your formula on for the torque, BINA. Okay, it's the same for question number 17. Okay, to calculate the maximum torque, again you have an angle which is B to the normal of your plane. Okay, or you have your normal, okay, plane here is 90 degree. So substitute into your formula, okay, sin 90 is equal to 1. So you just use this formula, torque equal to BINA, to calculate the value of the torque. Okay, I think you got question for number 17, okay, which is it's similar like uh, question number 5. Okay, uh, you have a length of your wire here, okay, and then bend into make or bend into the circular coil. Just imagine here you bend your wire into the circular coil. So then what happened? Okay, you have your circumference of your wire of your circle here. So here you need to use the 2 pi r. Okay, so you, because you want to calculate the area of your coil, the area here, the area of your coil, the area. So how to calculate the area? You have pi r square. Okay, pi r square. Okay, so you need to calculate the value of your r first here from the circumference of your coil. Okay, which is equal to 7 cm. Change to the meter, 0.07. Okay, is it okay? Okay, let's go to the new or next question. Okay, next question number 18, which is under the torque on a coil. Okay, let's read the question here. Okay, you have your turns, which is 20 turns, okay, and then r radius of your coil, okay, 0.5, okay, current inside your wire 0.4, okay, and then the wire have the top of coil in the plane of the coil makes an angle of 55 degree. Okay, so here you can refer to your figure here. You have angle plane to the magnetic field B. This is your magnetic field B. Okay, this is your magnetic field B to the right. Okay, this is the magnetic field B direction to the right. Okay, B to the plane. Okay, this is your plane. Okay, this is your plane. You have an angle is 55 degree. Okay, but when you want to use this formula of the torque, okay, NVIA sine angle, the angle you need to measure is from the normal of your plane, okay, the normal of your plane to the magnetic field B. Okay, so how to calculate the angle between the normal to the B here, normal, okay, to the B, you need to minus 90 degree, okay, to minus to 5 degree. Okay, so the value of your angle, you need to substitute into your formula is 5 degree. Okay, if you are not consider your angle correctly in your calculation, the rest part is wrong. Okay, so the final answer will be wrong. Okay, so the angle must be correct when you substitute into your equation. This question, okay, this problem, you have to calculate the torque. So you have a formula for the torque, NBIA, sine angle. But the angle you need to refer back to your figure or in your question. The angle is from which part to which point or which direction. Okay. So, but you need to substitute the angle into your formula. Here is the angle from the normal of your line here, the normal of your plane to the B. Okay, normal of your plane to the B. Okay, is it okay? Is it clear? Okay, next question. Okay, let's do question number 12, number 13, number 14, and number 15. Okay, if you realize that this question is under the topic force between current carrying conductor. Okay, what happened between the two wires? Is it attraction or repulsion? It depends on the direction of your current. It depends on the direction for each current. Okay, you need to consider the direction of your current for this concept. Okay, let's do some of revision. Okay, for the force between the current carrying conductor. Okay, so first we have a current flow. Okay, in the same direction each wire. Okay, magnetic field is opposite direction. We have similar to unlike magnetic poles. Okay, so see what happened to the between the two wires, attraction. Okay, they attract to each other. How about when you change the direction of the current? Now the current is in opposite direction, each wire. Okay, let's see here for the B is, okay, if you see from the top is anti-clockwise and this one is clockwise, which is opposite direction. Okay, so the force is repulsion. They repel each other. So you can see what happened to the direction of your current, what happened to the force between the two wires, and third, okay, what happened to the magnetic field B for each wire. Then you can calculate the magnitude, okay, of the magnetic field B. Okay, this is talking about the direction. How about the formula? So the formula is here. Okay, if you want to calculate the magnetic field B for each wire, you have formula B equal to mu naught I divided by 2 pi D or 2 pi R. Okay, this one F divided by L for this question. If you refer for this question, they want you to calculate the force, okay, per unit length. Okay, so you need to use this formula. Okay, let's do the how to calculate, how to find the magnitude and direction of the net magnetic field B at point A here. Where is your point A? This is your point A. Okay, so if you refer back to this question, okay, you have your current direction is in opposite direction. Okay, so before that, you need to calculate for the value of your B1 and B2. The same goes to question number 13 here. Okay, number 13, you have a two wire A and B. Okay, the distance between two wires 0.10. You have a value of your current each wire 5A and 3A respectively. Okay, then you have a direction of your current. Okay, so opposite to each other. So you need to remember the concept. What happened to your force of your wire between the two wire? Okay, attraction or repulsion, and then what happened to the magnetic field B? Okay, so you need to show, you need to label the direction of field force acting on this wire for question B here. This one to calculate the magnetic field B, okay, due to each wire means you need to calculate one by one. Okay, number 14 also you want to calculate force per unit length. Okay, you can use this formula, force per unit length. Okay, you want to calculate, sorry, this one you want to calculate the current, okay, on the second wire. Okay, so you can use this formula to calculate for your second wire. Okay, for number 15 is same like number 12. Okay, the magnetic field B, but now midway. Okay, magnetic field midway between the two long straight wires. Okay, so you can see here the direction of your current. Okay, the direction of your current. Okay, let's do the solution for number 12 first. Okay. Okay, for number 12 here, okay, you have direction, the direction, both of the current are in opposite direction. Okay, let's say view from the top. Okay, so here you have a current out of page, you have a current here into the page. Okay, so you have your current between the two wire is in opposite direction. So what happened to the force between two wire? Okay, attraction or repulsion. Okay, refer back to your concept. Force between two wire is repulsion. Okay, they repel each other. Okay, so when you draw the direction to show the force between the two wires, so first wire to the left, second wire to the right. Then, by using the Fleming left-hand rule to determine the direction of your magnetic field B, can you try now to show the direction of the magnetic field B at point A? Okay. So, first, by using the left hand, okay, you have your current is out of page. Okay. And then your F, okay, to the left. Okay, then what happened to the magnetic field B direction? The magnetic field B direction is going up. Okay, so B1 here. How about the B2? Okay, so B2 produce. Okay, produce at point A here. Okay, by using the Fleming left hand rule, now you have a current into the page. Okay, and then the F, the thumb. Okay, your thumb must go to the right. Okay, then what happened to the direction of your magnetic field B? First finger is going up. Okay, so you need to show at that on point A. Okay, so you have B2 here. So see, the B direction due to the wire 1 and due to the wire 2 is both is going up. Okay, so both is going up. So how to calculate the B resultant? So that's why you have B1 plus B2. Okay, B1 plus B2. But before that, you need to calculate the value of your B1. Okay, the value of your B2. Okay, at point A. Okay, please check the distance. Okay, substitute the correct distance or the radius here. Okay, so if you want to calculate the magnetic field B due to the wire 1 here, Okay, at point A, you have a radius which is 0.03. Okay, for wire 1. Okay, and then wire 2 here, the distance from wire 2 to the point A. Okay, you have R is 0.02. Okay, 5 cm minus 3 cm, you got 2 cm. So convert in meter, you have 0.02. So for B, for wire 1 and wire 2, and then you need to add to calculate the B resultant. Okay, so direction, okay, B upward. Is it okay? Do you understand or not? For question 12, how to solve your problem, you need to clear with the direction first. Okay, what happened to the force between the two wire? When you have the current, okay, both the current are in opposite direction. Okay, next question. Let's try. Okay, another question which is under the force between the two wire. For question number 15 here, okay, it's the same. How to solve? The working, the method is the same like before question. Okay, you need to see again the direction each wire. Is it if both current in the same direction or both current are in opposite direction. Okay, if you refer back to your question for number 15, okay, you want to calculate the value of your V, the magnitude, the resultant, the magnitude of your magnetic field B at point A. Okay, so where is your point A here? This is your point A. Point A. Okay. First, when you have a current, if both current are in same direction, so you have a current in the same direction. Okay, from the side here. Okay. So what happened to the force? They attract each other. Okay. So what happened to the magnetic field B? Okay, you need to choose the direction by using the Fleming left hand rule. You can try here. Okay, so at point A, the magnetic field B due to the wire 1 here. Okay, you have your current is going up. Okay, and then you have a force to the right. Okay, and then your magnetic field B is going up. Okay. Next, second wire, okay, you have your current also going up, okay, but your sorry, your your you have your force to the left, okay, you have your current going up, okay, your B is out of phase. So you check again for the first wire. So you have a dot here, okay. Let's try redo. Okay, for first part here, okay, you have your current, okay, if both current are same direction, okay, draw the current, okay, pause the attract each other, okay, draw the direction of your force, okay. Now the B, okay, pause to the right, okay, pause to the right, and then you have your current, okay, your pause to the right, your current is going up, and then you have your B is, okay, out of phase, okay, and then current going up, okay. Second, wire, you have your current going up, okay, and then you have to the left, and then what happened to the B at point A is into the page. Okay, so you have the direction of your magnetic field B at point A is opposite to each other. Okay, so B1, okay, minus B2, or here you have your calculation, okay, because you have the same, okay, so you have your B minus B2 or B2 minus B1. It doesn't matter because you have the same value, but it depends on your question, okay. So you have your same value here for the B1 and B2. So if you minus, you got 0. So you can cancel the B. Okay, so B is equal to 0. How about the second? Second, you have a current, let's say you have going up here. This one you have a going down. Okay, then what happened to the force for each wire? Okay, the magnetic field B at point here. So let's try. First wire, you have your current. Okay, your current is going up. Okay, and then your force to the left, and then you have your B1. Okay, into the page. So you have a cross here into the page. Okay, and then second wire, you have a current going down. Okay, and then you have a force to the right. Okay, so your B at point A, okay, also into the page. So cross. Okay, so cross here, then you have also cross. Okay, each wire. Okay, at point A. So same direction you need to plus. In opposite direction you need to minus to calculate the B, the resultant of your B, the resultant of your magnetic field B. Is it okay? Okay. Let's look the next question. Okay. Okay, next question, you have a circular motion of charged particle. Okay, so let's do question 9. Okay, also you can refer to this figure. Okay, what happened to your charged particle when you place in the uniform magnetic field B? Okay, magnetic field B. Okay, your charged particle will move in a circular motion here. Okay, so here you have a proton, your charged particle, okay, moving in circular orbit perpendicular to the magnetic field B. Okay, you have your angular, okay, angular velocity. Unit is radian per second. Do you remember or not? Okay, your angular velocity from physics 1, okay, under the rotational motion, okay, angular velocity or omega, okay, unit is radian per second. Okay, first you want to calculate the period of the revolution, the period, the t term here. Okay, by using this formula omega equal to pi f or 2 pi t here, then you can calculate for the t. I think you are very familiar with this equation formula. Omega is equal to pi f. Okay, and then you can calculate the period here, 3.2 times 10 power negative 4 second. Okay, question B. Okay, you want to calculate the magnetic field strength of the field here, the B value. Now you have a charged particle move in the circular motion. Okay, so you need to apply the formula here. R equal to mv divided by the qv. But here you don't have a R value. But okay, you have the information. Okay, for the omega, angular velocity. You have a value. Do you remember or not this formula? The relationship, okay, the formula of the relationship between the linear velocity. You have a linear velocity here, v, and then you have a angular velocity, which is omega. So, by using the formula relationship between the linear velocity and the angular velocity here, you need to substitute, okay? So, you have a formula, substitute into your v term here. Okay, so you can cancel for the r here and r here, no more r, then you can solve for the v. V equal to m omega divided by the q. M is referred to the mass of your proton. Okay, then you can calculate the final answer here. Okay, let's do the next question. Okay, question number 19. Okay, actually this is under the same topic. Okay, circular of charged particle, circular motion of your charged particle. You can see here the same formula you need to solve, you need to use to solve your question, your problem. R equal to mv divided by qv. But before that, if you refer back to your question, okay, for 9a, you want to calculate the magnitude of the magnetic flux density, the B value. Okay, you have your charged particle, which is electron, moving at velocity here. Okay, enter a uniform electric field. Perpendicular means here you have your electric field, you have your magnetic field B. So what happened to your charged particle? To keep, okay, the electron, so the electron beam undeflected a uniform magnetic field B. What happened to your charged particle? Your charged particle, the electron will move in a straight line without deflection. When you apply the E, the uniform magnetic field E, and the uniform, okay, the uniform magnetic field B. You apply both electric field and the magnetic field B. So this is under the motion topic, motion of, okay, part, which is motion of charged particle in the magnetic and electric field. So this is your formula. You have your charged particle move in the straight line, okay, without deflection. So your charged particle must have a velocity. So this is the velocity of your charged particle equal to E divided by B. So you want to calculate the B. Substitute the value of your E and the E here and the velocity of your charged particle to solve, okay, to calculate the value of your B. Okay, again, here, next question B. Now question B, electric field is suddenly switched off. Okay, then you need to calculate the radius, okay, for the electron circular orbit. So what happened to your charge particle when you switch off the electric field E? Now you have only the magnetic field B. So when you have your magnetic field B only, what happened to your charged particle? Your charged particle will move in a circular motion. Okay, so your charged particle will move in the circular motion. When you have your charged particle move in the circular motion, you need to apply this concept, or you have this formula R equal to mv divided by qv. Okay, so substitute here. You have a mass of your electron. Okay, the velocity of your electron, and then your charged electron value. And this one is the magnetic field B from the first part here. And then solve for the R, radius of the electron, circular orbit. Okay, move in circular motion. Do you understand or not? Okay, so how to make your charged particle move in the straight line? When you apply both electric field and the magnetic field B. Okay, when switch off, when you don't have your electric field E, you have only the magnetic field B. What happened to your charged particle? Your charged particle will move in a circular motion. Okay. So next, or the last question. Okay. You have the question, or which is under the charged particle. Okay, motion of your charged particle in the magnetic and electric field together. Also, you can refer to the last part on from your notes. Okay, motion of your charged particle in the magnetic and electric field. What happened to your charged particle? Okay, when you apply both electric field and magnetic field. Okay, so here uh, you have a question here. Now it's given the value of the energy. Okay, the distance between the two plates is 15 cm. Okay, and then you have a potential difference across the plate is 120. Okay, let's do the working here for the part B. Solution for the part B, they want you to calculate the of this magnetic field. Okay, you have your, if you refer to your question A, you apply, okay, of the, you need to apply, okay, you apply the magnetic field B, okay, so that the electron move and deflected parallel to the plane of the electron move in the straight line. Okay, so they want you to calculate the magnetic field B. First, you need to calculate the value of your electric field E applied to your charged particle. Now you have an electron. Okay, your electron. Okay, so how to calculate the electric field E? You have a potential difference or the voltage here. Okay, you have a distance between the two plates here, 15 cm. So E is equal to V divided by D. Okay, so you have 800 volt per meter. Refer back to your formula. You have volt, potential difference divided by the distance, unit in meter. Okay, refer back, okay, to your question. You have the energy, the kinetic energy here in the unit electron volt, kilo electron volt. Okay, so you need to change to the joule. Okay, this is the conversion unit. Okay, the when you convert the kilo electron volt to the joule, you got 3.2 times 10 power negative 16. Okay, you have conversion unit here for 1 EV equal to 1.6 times 10 power negative 19. Okay, you want to solve for this question for the B, you must have a B, and also you must have a velocity of your charged particle, the electron. Okay, so by using the energy here, the kinetic energy, okay, you need to calculate the value of the V. Okay, you get this value 26.5 on 10 power 6 meter per second, the velocity of your electron. And then here you have the value of your electric field applied on your charged particle, which is 800. Substitute into your formula to get the value of your magnetic field B, which is 3.02 times 10 power negative 5 Tesla. Okay, is it okay or not? Okay, how about the diagram? Okay, how to show the direction of your applied magnetic field? Okay, so that the electron move undeflected parallel to the plates. Okay, so let's look how to draw the direction. I hope you understand. Okay, Okay. Let's do this part, motion of the charge particle magnetic and electric field. Also, you can refer to the last part of this topic if you want to in your notes. Okay, how to draw your direction of your magnetic field B. Okay, and you need to also show the direction of your electric field. So then, okay, you can see what happened to your charge particle. Your charge particle will move in the straight line without deflection. Okay. For question 28. Okay, refer back to your question. You have your upper plate is lower potential. Your okay, uh, lower plate is higher potential. So you have a negative plate on the top and positive plate on the bottom. Okay. So first, you need to draw the direction of your electric field E. Remember your electric field always from the positive to the negative. Okay, so this is the direction of your electric field. You need to apply on your charge particle in your plate, between the two plates. So it's going up. Second direction, okay, you need to draw is the force due to the electric field E. So you have your electron. So the direction of your Fe must opposite to the direction of your electric field E because of the charge particle is negative. Okay, if you have a positive, then your Fe is the same direction with your electric field E. Okay, next. The direction is the force due to the magnetic field B. You want to cancel all the force. So Fe must opposite direction with the Fe. If your Fe is going up, your Fb must going down. Okay, now your Fb is going down, your Fb must going up. Next, you want to draw last is the direction of your magnetic field B. Okay, see, by using the Fleming left hand rule. Okay, to the right you have a direction of your charged particle. Okay, Fb is going up, so your thumb is going up. Because of you have your electron, okay, your direction of your charge must in opposite direction. You need to turn, okay, so from the right to the opposite direction. Okay, understand or not? If you refer back to the previous part, okay, for the Fleming left hand rule, you have your second finger. The direction of your current is the same with the direction of the positive charge particle. Okay, so if you have a positive charge, the direction is to the right. Okay, it's the same with the direction of motion of your charge particle to the right. You can refer to the V direction here. But now you have your electron mass in opposite direction. So what happened to the B? The direction is out of phase. Thanks for watching. See you for the next tutorial.